Okay, this is CIS1103 week 9 and 10, internet layer and routing. The internet layer deals with packets. It will deliver packet to specified network destinations. So it is linking between networks, different networks or different LANs. And the most famous protocol or the main protocol in the internet layer is IP, Internet Protocol. We have two types of IP. We have IP version 4 and IP version 6. The IP version 4 address is a logical network address that is given to a host in order for the host to be able to communicate on the internet or in the network. Okay? IP version 4 can be given to workstations, servers, even IP phones, network printers. Router interfaces that provides connection to an IP network will also have an IP version 4 address. So if your router have physical interfaces like fast Ethernet or Giga Ethernet, each interface of the router should have an IP address. Every packet sent across the internet has a source and destination IP version 4 address. So here in this example, we have a host communicating with these computers or servers. Each one of them should have an IP address. The IP address, I think we have mentioned this before, is 32-bit, 32 binary bits. They are grouped into 4 8-bits, and each 8-bit is called an octet. And the octet is entered in a dotted decimal number. Here we call this dotted decimal numbers. Dotted, there is a dot. Decimal, 10, 192.168.1.5. There is no dot at the end, okay? The 32-bit binary equivalent of this number is this number. Okay? So the 5 is equal to 101, 1, 2, 4. 4 plus 1 is 5. Okay, we will discuss, inshallah, about this. We'll give you some examples. So the binary conversion of IP version 4. The rightmost bit in an octet has a value of 1, and the values of the remaining bits from right to left is 2, 4, 8, 16, 32, 64, 128. If I have this number here, please let me magnify it. Here, the first one is equal to 1. This is 2, 4, 8, 16, 32, 64, 128. So the 8-bit is equal to 128 if it is 1. If it is 0, it is 0. Okay? Is this clear? So if I want to calculate the decimal equivalent of this number, 111,00100, converted into decimal, it's easy. It is 1 plus 2 plus 4 plus 32. Why I did not put 16 and 8? Because they are zeros. Is it clear? Have you done similar things like this before? Let me repeat it, please. This is important. Here, I have 1 plus 2 plus 4. This is 8 and 16, but because they are zeros, I don't count them. And then I have 32. So it is 1 plus 2 plus 32, which is 1 plus 2 plus 4 plus 32, which is equal to 39. Is it clear? Shall I repeat it? Again, here we converted into its decimal equivalent. So it is equal, 1 is 1. The second one, 1 is equal to 2. So 1 plus 2. The third one is equal to 4 plus 4. This is 8, but it is 0, so it's not counted. And this is 16, but it is 0, so it's not counted. This one is 32. It's counted, so it is 1 plus 2 plus 4 plus 32. Okay, which is equal to 13. Now let me ask you a question. 1, 1, 1 is equal to what?
3.
No. 1, 1, 1 in binary is equal to what in decimal? Take your time. Yeah, 7. 1 plus 2 plus 4. What about 1, 1, 1, 1?
31. 23.
Just write it. It's 1 plus 2 plus 4 plus 8. 15. All right? What about 1001?
39. No. No?
None. If it is only 4 bits, there is no way you can get more than 15. All right? We will do some exercises on this. Next. So this is the way to convert. As you can see here. So 1 plus 4. So if I have 101, it is 1 plus 4, it is 5. If I have 1 only, 1. If I have 0, 0, 0, 1, 0, 1, 0, 1, it is equal to 8 plus 32 plus 128. Okay? You can write it down and do it by yourself. All right? By the way, some calculator does this conversion, but you are not allowed to use these calculators in the exam. Okay? So here you need to try. So let's do this one here. If I have 0, 0, 0, so 3 zeros, 6 zeros, and 1, 1, it's equal to what? Here, 0, 0, 0, 0, 0, 0, 1, 1. This one is equivalent to 64. This one is equivalent to 128. So it is 192. 192. It's 128 plus 64. Okay? Please, everyone, please pay attention. This is important. You will definitely get questions about this. The IP version 4 address structure. The IP version 4 has 2 parts. The first part is the network address or network ID and the host address, host ID. So in this here, class B, what is my network address? My network ID is 172.16. My host ID is 30.56. How do I know the network address, the network ID and the host ID? By using the subnet mask. If I know the subnet mask, then I can know what is the host ID and the network ID. Subnet mask. What is subnet mask? We always hear about the subnet mask. Subnet mask is same like the IP address, 32-bit. But it allows the recipient of the IP packet to determine what is the network ID and what is the host ID okay? So I have an IP address. If I have subnet mask, I will do a logical AND between them. Then I can find out what is my network ID and what is my host ID. We'll show you some example of how it works. Logical AND. In logical AND, only 1 and 1 is 1. The other cases are 0, like multiplications. When you get 1, only if you multiply 1 by 1. If you multiply 0 times 1, 0. 1 times 0, 0 times 0, 0. Okay? So to identify the network address of IP version 4, the IP4 address is logically ANDed. Logical AND. Bit by bit. Okay? ANDing between the address and the subnet mask yields the network address. This is the IP version 4 address structure. To illustrate how AND is used to discover a network address, consider a host with IP version 4 address, and this is your subnet mask. So here we have 192. I am converting each octet into its binary value, and 255.255.255.0 I converted into binary. So here all ones, all ones, all ones. If I have all ones, yani 255, and then 0. If I do logical AND between them, I will find out my network ID. And what is my network ID here? Who can tell me, please? What is the network ID for this address? What is the network ID? Look here. We did AND. What did we end up with? This is my network ID. What is it? 192.168.10.0. This is my network ID. What is my host ID? 10, the remaining. All right? Because my subnet mask is 255.255.255.0. This means that the first 3 octets are my network ID. The last octet is my host ID. We'll do some examples, inshallah. Now, the world or the internet governing societies or groups, they have defined some classes for IP version 4 address. We have class A, B, and C. Okay? And D and E. Class A, please, you have to know these things. Class A can provide you with total networks of 128. Total hosts of 16,077,000 plus. Okay. Class B, the first 2 octets are for network ID. The other 2 octets are for host ID. So here it is balanced. You have network ID is 16,000, host ID is 65,000. The third one is class C. Here we have total networks. We have 3 octets for the network ID, and we have 1 octet for the host ID. Okay. Class D and E are only 12.5% share. Class A. Class A range is from 0.0.0/8 to 127.0.0.0/8 also. /8 meaning that the first 8 bits are my subnet. Yani my subnet, if I see /8 meaning that my subnet mask is 255.0.0.0. If it's a /16, it means that my subnet mask is 255.255.0.0. If it is /24, what does it mean? 255.255.255.0. Each octet is 8 bits. So if it's /8, it is 255.0.0.0. If it's /16, 255.255.0.0. Okay? In class A network address, the first byte is assigned to the network address, and the 3 remaining bytes are used for the host address. So it is network, host, host, host. For example, 10.0.0.0, and this is the network ID, and the hosts are .1 or .255, .255, .254. These are all hosts. And what is the broadcast? The broadcast address that will be sent to everyone is 10, the network ID, and then for the hosts, I will put all 25, 255, 255, 255. This is the meaning of broadcast because I'm sending to everyone. So I will put 111 for all the octets. Class B, here we have network ID. The first two octets are network ID, and then the third octet is host, the fourth octet is host. For example, we have 172.16.0.0 is a network. The hosts are like 0.1 or 255.254, and the broadcast is .255.255. The range of class B is from 128 to 191. And you see the prefix, it is /16 because the subnet mask is, it is 255.255.0.0. Maybe this is new for you, but we will give you some examples, don't we? Okay, we'll make it more clear. Class C is network, .network, and then the last octet is for host. Okay, and the range is from 192.0.0.0 up to 223 networks. Okay, example is 192.168.100.0, the one we use in the lab always. We have 192.168.100.1. The broadcast is 255. The last octet is 255. With addressing IP version 4, multiple logical networks can exist on one physical network. And I can have here in our building, we are the same physical location, but I can have each room or each classroom with a different subnet, okay, or logical network. If the network portion or of the logical network host address is different. The host with the same network number in their IP version 4 address will be able to communicate with each other, but will not be able to communicate with the other host without the use of routing. Okay? So the hosts with the same network number can communicate with each other if they belong to the same LAN. If they want to communicate with the other LAN, they have to go through the router. So if we look here, this network here, I have one, wait.